waterways.
When you hear about COVID-19 showing up in the water treatment system, if you're like me, you're probably thinking of a couple of things. First, how do they get the sample out? Second, how do they detect COVID when it must be there in such small amounts, right? Sudhi Payyappat is the microbiologist at Sydney Water who is the super sleuth who detects diseases in wastewater. In fact, Sudhi himself came up with the most effective method to accurately test wastewater for fragments of COVID-19. And he and his team of 20 stormwater sleuths have trained the water testing teams from around the country to detect COVID-19. Sudhi, welcome to the program.
Thanks for having me, Manya.
A pleasure, a pleasure. First of all, don't you worry about catching COVID-19 when you're carrying out this important work?
It's highly unlikely. SARS-CoV-2 is primarily a respiratory virus. It's not designed to be transmitted through water or wastewater. Unlike other viruses which are transmitted through water, this one is it's different. It's got a lipid envelope around it. And one good thing with that is, the lipid or fat is susceptible to soap. Soap dissolves fat. Therefore, it breaks open the lipid membrane so that the virus particles collapses and it's no longer infectious. And that's how washing hands for 20 seconds with soap became one of the best defense against this virus. Sewage also contains lots of these detergents and other substances that inactivate SARS-CoV-2, this virus, before it reaches the treatment plant. So far, there's no evidence to suggest that SARS-CoV-2 survives and remain infectious in wastewater. And of course, we will be wearing appropriate personal protective equipment, PPE, and of course following good hygiene practices.
So how does COVID-19 end up in the water? Why is it there?
Many infected people excrete this virus in their stools. People also shed virus while brushing their teeth or when washing hands or having showers. All this virus will end up in the sewage and then it goes to the wastewater treatment plant. As I said earlier, the virus in this treatment plant or the sewage, they will not be intact and it would have broken down, but the remnants of this virus's genetic material, which is RNA, will still be there in the sewage. And that's what we are actually looking for with the testing. For testing this virus, we have a research program with New South Wales Health where wastewater samples are collected from treatment plants across the regional New South Wales and also from Sydney metro areas, and they're transported to the Sydney Water Labs in chilled conditions.
And this happens right across Australia, I understand. So how do you find it? How do you find the COVID-19?
Okay, right. This wastewater testing is a bit challenging, especially when there are very low case numbers in community, like the situation we have right now. And also because of the massive dilution taking place when the wastewater reaches the treatment plants, the number of the virus particles in the 100 ml sample which we are testing can become very, very low. Wastewater is also a difficult matrix which contains a lot of compounds that could potentially interfere with the virus detection. So testing method has to be very highly sensitive. The testing process starts with a concentration step where a special membrane filtration technique is used to capture viruses fragments onto a membrane. So basically, if the virus is present in the sample, that will stick to the membrane. And in the next step, the virus materials are separated from the membrane And then the genetic material of this COVID-19 virus, which is RNA, or ribonucleic acid, is isolated and purified using different chemicals. And the final step is the amplification step. The specific genetic markers of SARS-CoV-2, if it's present in the sample, are multiplied millions and millions of times to enable detection by a process called reverse transcription quantitative polymerase chain reaction, or in short form, RT-qPCR. This will tell you whether the sample contains this virus fragments, and if it's there, how many.
So how do you narrow it down to such small areas?
Right, okay, this method what we have is very sensitive and picks up even very low numbers of this virus if it's present in a treatment plant. And usually the wastewater treatment plants have huge population catchments, so hundreds of thousands of people. And these are mainly served by many pumping stations. So if we get a detection in one of these huge treatment plants, then our New South Wales Health they would like to know where it's actually coming from, like whether we can do a tracking. So we can't do that by breaking down these huge catchment into the pumping stations and then further network sites, and then we can test from these locations to cover a smaller population catchments.
And I believe Sydney Water has just bought a shiny new machine which can speed up the process.
Yes, we are continuously improving our method, and New South Wales Health would like us to test more samples from the regional and the Sydney metro areas. So we introduced an automated nucleic acid extraction process so that we can actually double up our testing program, so that now we could test potentially up to 150 samples per week.
So what else do you look for apart from COVID-19? What are the other things you look for in the wastewater?
At Sydney Water, in the microbiology point of view, we test various water matrices like drinking water, source water, recycled water, and wastewater for various disease-causing organisms like bacteria, viruses, and protozoans. We monitor them to make sure we have high-quality drinking water, and also see the impact to environment is minimum.
And what about drugs?
We at Sydney Water, we do not test for drugs here, and those testings are done by external government agencies. We just send our agencies.
And I understand you teach other states how to do this through the Colossus program, which is the Collaboration for Sewage Surveillance for SARS-CoV-2 program.
Okay, when we initially started the method developments, the Colossus partners started working on different methods. Then we at Sydney Water got a detection with a special membrane filtration technique, and then shared it around our other research partners in Colossus. Since our method was very sensitive and fast and also cheap to run, other Colossus partners adopted this method to concentrate virus from wastewater.
How did you come up with the method for detecting COVID-19?
Well, it's all started in February last year when we heard the news that this SARS-CoV-2 virus was detected in a wastewater treatment plant in Netherlands. So then I thought it may be a good idea if Sydney Water also got a method to test for this virus in wastewater, which could potentially be used as an epidemiology tool. So then I put a project proposal to my management, and they approved, and then that's where I started.
So do you tell people what you do? Because essentially you deal with waste, human waste all day.
Well, yes, I do. Yeah, I know it's not a most glamorous job to do, but at the same time, it's very important. And then we see that here with this the wastewater surveillance for SARS-CoV-2. and that how it's helping to fight the pandemic and to support New South Wales health COVID-19 response. We know that testing the sewage can help provide early warning of an increase in infection in an area and also potentially identify if there is an undetected case in the community. So yes, it plays a key role.
Thank you so much for your time, Sudhi.
Thanks, Manyo.
Thank you so much. That's Sudhi Payyappat. He's the microbiologist at Sydney Water, the super sleuth who detects diseases in wastewater.